In this video, I will be explaining you how to create your own custom terminal commands in Linux using all these methods. My purpose of this video is to explain you regarding these methods. So I will take a simple enough scenario, but in your case, the scenario might be big and complex enough where the necessity of having a custom command is a valid one. Okay, coming to my scenario, let's say for an example, I want to see list of files in any particular folder. Now I don't want to see all the files. I want to see only those files which have exceeded 100k file size limit. Maybe let's say 1 MB file size limit. And I want them to be, I want those greater than 1 MB files to be displayed in this terminal in a sorted way, not in a random way, in a sorted way based on file size from least to biggest. For that, I've created a command using the existing shell commands. I've put together this command, and so what this command does is it tries to list out all the files inside whatever the folder that we mention. It will display only those files whose file size exceed whatever the file limit that we mention. In this, let's take 1 MB as the file size, and after filtering those files, the output should be in a sorted way based on the file sizes. Okay, so whatever the files that have been printed here are greater than 1 MB, and they are sorted in ascending order. A quick explanation about this. You already know what ls-l does, and this is the folder path, and I'm using awk tool so that I will be able to filter this fifth column for some file size, and based on that condition I can print the complete row. I'm using this tool for that, and using sort tool so that I will be able to sort these things in ascending order on fifth column. This sort has to be done based on the fifth column, and these fifth columns should not be treated as alphabets. These should be treated as numbers. That is what this n signifies. Okay, now this is my scenario. I don't want to I might want to see this kind of output over and over again at different times, and more than once. I don't want to keep typing this whenever I have to, like, see this kind of output in any bash session. I want to be able to reuse this particular logic in a simple command way, like how simple enough this ls nano and cat are easy to use. In a simple enough way, by just mentioning a command, this complete thing has to be run. That is my goal here. So whenever the concept of reusability comes, the first thing that comes to our mind is using variables. So let's try that. We'll try to keep all these, we'll try to place this uh, all this command inside some variable. As we are already inside a bash session, we can use bash variables var1, and I'll place this complete command inside this with quotations. Okay, and while we are using variable here, I want this to be, this $5 to be taken as a literal string rather than it to be something uh, to be replaced with. Now, if we see what is present inside var1, okay, the command is present inside var1, and our goal is like whenever we mention var1 in this terminal, this complete command should be executed and the output should be printed. For that, we cannot directly run var1 when we are using the concept of variables for creating custom commands. We have to we need to use one other tool called eval. What this eval does is it takes whatever the variable that we mention in here, and whatever the string that is present inside this variable, it considers it as something to be further executed. So that is how this eval helps us. Now eval var1, if we do that, uh, sorry, eval $var1, if we do this, it considers this var1's value as some command that needs to be further executed, and the output is printed here. Okay, we just saw how to create custom commands using variables, but you might have already noticed this is not how we use ls or cat or nano. We don't give eval under $ls, we just type ls. We want to achieve that. So for achieving that, we cannot use these bash variables. We have to use some other concept called aliases. Alias, as its name itself mentions us, it's alias means a different name for something. So I want to give this complete commands for this complete command some name, some alias I want to give. That let's say this is the alias I want to give, cmd in alias. Okay. Now similar to variable, I will paste this complete command inside this alias. Now alias is the cmd in alias is defined. You can see all the available aliases by typing this, and our cmd in alias is present here. Now, unlike how eval is needed for variable, we can just straight away type cmd in alias here, and we get an output. This now we are one step closer to like creating custom commands in terminal that resembles these ls or cat nano way of executing these custom uh, normal commands, and this is a custom command. Okay, now even though alias solves one problem from variables, it has another problem, that is I don't want to use this where this command to always see the folders that are the files that are present inside this folder itself. I might want to see I might want to use this same command with the different folders, and I might also want to filter with the different file size thresholds. For that to be able, for that to be achieved, these things, instead of hard coding them, we have to replace them with some argument structure, like something that needs to be filled here during the runtime rather than this defining time. For that, what we have to do is like ls hyphen l, instead of this folder, we need to give we need to give argument like $1, and here we need to give replace this with argument that is $2. And one shortcoming of aliases is it does not support the passing of arguments, unlike how functions of scripts functions of bash functions support arguments. So Even though this is one step closer to creating our custom command, it is very limited in its functionality. For us to be able to use it dynamically during runtime, we need to use bash functions. Now we just finished variables and aliases. We'll see how we can create custom commands using functions. To save time, I have already defined these things. Okay, this is a bash script, and inside bash script I have defined a function that is my function. You can replace with any name which you want it to be used as a custom command. So here the definition is simple, some echo commands, and inside function also we have some echo commands. And this is the important part. Whatever the use case that we have simplified into commands, this is the command. Instead of hard coding our um, folder and file threshold size, we have given it as arguments. Now whenever this function is invoked, it this function also expects some arguments, first and second argument after that. Those will be placed in $1 and $2. This command is inside variable, and it prints us for our debugging. And after that it will try, after a runtime replacement of these arguments with proper values, it will evaluate and runs this string as a command. Now let's see this. I am already inside that folder where the file is present, and I will source that file so that the function will be defined and we can directly use the function uh, without having to bother about the file names. I'm sourcing it to define the function, and it has been properly interpreted. Next, my function is defined, right? We can directly use it as my function, and we'll pass the folder name and our file size threshold. Let's say 1 MB, 100 bytes, 1 KB, 10, 100, 1 MB. Okay, this is done. Uh, it is exactly similar to how we use ls or nano, all the existing commands. We can even change the file size to 10 MB, and we can even change the folder that we want to check this on. Let's let's try to see, let's try to pass this folder itself. uh, and I don't think there is any file greater than 100 MB, so let's reduce the limit. Okay, all the files are above 100 bytes and in sorted manner. Let's do 300. Okay, above 300 in a sorted manner, all these files are there. Now this functions is also we have seen to create custom commands, and at this point itself all your most of your uh, use cases can be uh, converted into custom commands by using functions and its logic inside itself. But we'll see these ways as well. We'll open scripts, command in scripts, and what I've done is I've just removed that my function, and uh, my intention here is, instead of using the function name as the command name, I want to use the file name as the command name. So I removed the function, and I straight away kept I straight away defined these commands here, and whatever the arguments that this file receives, they will be replaced here. Let's see it in action. Before executing, you have to convert this file as executable. I mean, the permissions have has to be changed to executable. I changed I changed its permissions to executable. Um, let's see by running it. And we are passing arguments now. $1 is folder and $2 is file size, and it is giving the output. But if we look at this, this is not what we want. We just want cmd in script. So let's try to remove this .sh, and I've already done that. I removed it and renamed it to cmd in script without extension to avoid confusion between these two. Let's try to run that, and obviously that file has also has to be given the permissions of executable without extension and arguments. Okay, it is working, and to check uh, its fluidity, we'll just change the values to, we'll give 400. Yeah, it is doing as we expect it to do. And now one more, without the extension also these shell scripts work. And now we want to remove this dot slash. We'll try that as well by removing, by not using dot slash and directly running this command. Okay, now it raised an error. The reason why it raised an error is whatever the this particular structure means, the name and this arguments, this terminal sees it as some binary file which is present in one of the folders, uh, in one of the paths that we mentioned in path variable. So generally all these ls, cat, nano are all binaries, are binaries which are written in C language, and their binaries are present in slash bin. You can even go and check inside the slash bin. We'll do it here itself. So this is the binary of ls. Now in our case, our file is not a binary one, and that's not a problem. It works fine even on shell scripts. If we just take this without extension shell script and place it inside any of the path that are present inside path variable, it works fine. But general practice is to take these kind of binary files and place them inside slash bin. But we, for our case, we'll try to add our path itself to this path folder. Okay, now the path has been added. Now, whenever we run our custom command by which was created from script shell script, what it does is it goes into path file and first tries to see if there are any binaries that are present inside all these paths in this particular order only. So it's not a binary, but it's still a file. So it and we did give uh, a hashbang sequence of which interpreter to use while running it. So everything that it needs to run this file has been given. Now it runs fine. To eliminate this dot slash, we just have to add. We either have to move this file to slash bin. That's a good practice that is generally used, or you can add the existing path to existing this file's path to path variable. Okay. Now we have seen all these four ways. Okay. Now let's see it using this using C, Python, and Java as well. And I have already created these things as well to save time. Uh, in C file, what I've done is I've recreated these this our use case command we have created, right. That I tried to dynamically create that and run that shell command inside C file itself using this system. What I'm doing inside C is exactly this. Here I'm dynamically creating the command and running it. Okay, now if you are inside Linux related operating systems, all these uh, compilers and interpreters have to be installed. Just check once. Uh, f- for me to execute C file, I already have GCC compiler installed. It is installed. So, and to create a binary file, we just have to run this command gcc and whatever the .c file and output it to whatever the binary name that you want. And I've already done that and created this cmd in C binary file. And based on our previous discussion, a good practice is to go and place that binary file inside this slash bin folder. But anyhow, we have added this our directory itself to the path. We are expecting it to work fine, uh, even if we did not move this file. So dollar first argument is file folder path and second is file size. And of course change its permission to executable. Arguments, let's take these arguments itself. Okay, it is working fine with C as well. Now coming to Python. And Python, you will have an inbuilt Python interpreter that might have already come with your Ubuntu. Um, Inside Python, I'm not creating that complete command. We'll just do hello, uh, hello, and with an argument. It's similar to our use case only. and to execute it as a script, we have given its hashbang sequence, which interpreter to use. And based on our previous discussion, these things will work fine without having the proper extension for these files. So I created cmd in Python without extension. The content is same. Now it will work fine. This cmd in Python, change it to executable. Give any name. It works fine as a command. And inside this file, you can even rebuild your own use cases custom command. And mostly whatever the use case that you have, it will have been solved by these three itself. But suppose in case you want to use some libraries that were explicitly present only in these programming languages, you can use these ways. And same thing with Java as well. Okay. uh, in Java, here also I have given hashbang sequence to use user bin Java source 18. So, and here also I made it, I want to keep it simple, hello with an argument. We'll try to run and see if it works or not. And I did not give any extensions here also. Usually dot Java will be present. Change its permissions to executable. It's working fine. So again, usually we are supposed to keep these things in slash bin, but this also works fine. Okay, that is how we create custom commands using these ways. And now coming to this point, making these things that we define, and how to make them available system wide. What I mean by it is, for these variables and aliases and functions, we have defined inside this bash session, right? Before trying to actually execute it, we try to uh, source them or define them inside this shell session. uh, s- so let's take an example of my function. We already sourced it inside this function, inside this session. My function, and let's do slash bin and some file size. It works fine here, but here, if I try to do the same thing here, it does not work in a new bash session. It does not work because it is not actually defined in here. For that, I have to source it again. In case of variables and aliases, I have to define explicitly here again. So to eliminate all that redundant work, one solution for that is we have bash rc file. So whenever a new session is being created, this dots bash rc file will be the first thing which will be run in any new session. So we can, it's a shell file, so we can directly go in there and define our variables or aliases or functions inside dot bash rc to make them available system wide, and to avoid these redundant definitions over and over again. That is it for this video.